what we can conclude here is that using a periodic table, we can actually predict what kind of chemical reactions a particular element will undergo, and based on where they are in the periodic table. So the elements in the same group undergo similar type of chemical reaction. Now, the question here is that if I give you a multiple list of different elements in there, is that which list, elements in which list will undergo the same type of chemical reaction? Well, you will have to identify each of the elements in the periodic table, and if one of the lists there, if you see all the elements belongs to the same group in the same column, then they will undergo similar type of chemical reaction. Okay? So we can actually use periodic table to make predictions. So sometimes we don't really have to do everything. Based on the theory, based on the knowledge that we already know, we can make predictions without even doing the experiment there. Knowing sodium metal will react to chlorine, give you sodium chloride, potassium, cesium, they belong to the same group there. Even hydrogen. Okay, hydrogen react with the chlorine gas, and you end up with HCl, hydrogen chloride. Okay, and the sodium, potassium, cesium, they will undergo similar type of reaction, form the same type of compound, similar type of compound, if you will. Okay, for the periods though, we say the periods are the horizontal row. There are 7 rows in there. Okay, and each row has a different number of elements in there. The first period, you only have 2 elements in there, hydrogen and helium. The second period, you have second and third period, you have a total of 10 elements in each. Period number 4, you have 18 elements in there. Okay, so this is the organization of the periodic table. Now, how do we categorize the periodic table? How do we subdivide the periodic table so that we know part of the periodic table represents the metal elements, part of them represent non-metal elements? Well, the thing is, on the left side of the periodic table, those are the main group metal elements. On the right side, we have non-metal. So we'll try to color code this thing. The lighter blue is the main group metal. The yellow color is the non-metal. Okay, and the darker blue, or if you will, we'll call it purple there, this is the transition metal. And then transition metal, meaning the properties of the elements is transitioning from metal to non-metal. And here we have metalloid. So the elements in green color, in the green color there, represent, they may exhibit some type of metallic property, and they may also exhibit some type of non-metallic property. So they're somewhere in between. These, however, we call them transition metal. These are metal elements. Everything in here are metal. Main group metal, transition metal. They're different. Now the difference there is that main group elements and metal elements will lose when they react with other non-metal elements there. They will give out the same number of electrons depending on which group they're in. Transition metal is a different story. Transition metal elements there depends on who they're with. Sometimes they like a particular element more than others, and they will give out a different number of electrons there. Okay, so for transition metal elements there, the number of electrons that can be transferred to other non-metal elements and depends on the situation, depends on which non-metal elements they're with. And also sometimes then you can say like iron is a transition metal. You can have iron chloride, FeCl2. You can also have iron chloride, FeCl3. So iron metal, the atoms of iron metal can actually take 2 chlorine atoms there, and it can also take 3 atoms there. So that makes things a little bit more complicated, simply because there is no fixed number of electrons that they are giving out, depending on the actual situation. Compared to the main group elements, however, main group elements will give out a fixed number of electrons. If you are group 1A elements, you will give out 1 electron. If you are group 2A metal element, you will give out 2 electrons. Okay, so this is the basic organization of the periodic table. There we have different categories there: metal, non-metal, transition metal, metalloids. Okay, and metals, comparing the physical properties there, metals would all have metallic luster. You see that silver and gold, and they always have that metallic luster there. Non-metals, most of them don't. Okay, and with the exception of graphite, and graphite carbon, actually sometimes you see a little bit metallic luster there. Okay, now metals stay at room temperature. All metals are solid except mercury. Okay, and the only exception for the metal elements is mercury at room temperature is a liquid. Everything else, in terms of metal, everything else is a solid. Non-metal, however, can occur in all three states. Hydrogen is a gas, oxygen is a gas, okay, and bromine is a liquid, iodine is a solid. So non-metal can exist at room temperature. Non-metal can exist in all three states. And metals are, we call it malleable and ductile, meaning you can compress it, you can stretch it to an extent. Okay, so that's why you have a piece of copper there. Yesterday when we were doing the calculation there, one of the dimensional analysis questions there, you have a block of copper metal, you can stretch it into copper wire. Okay, so there is to some extent, you can actually de-shape it and then stretch it and compress it. But non-metals, normally you can't do that. If you try to compress a non-metal, you will break it. And if you try to stretch it, you're going to break it. So they're brittle. Okay, and metals are good conductors. That's why we use copper wires and electrical. We use copper in electrical wires there. So good conductors, meaning electricity will go through. Non-metal, most of the non-metals are poor conductors. I say most. Some of them get into the details there in semiconductors there and use the silicon, doped silicon, and even graphite, and those are conductors there. But most of the non-metals are poor conductors, meaning electricity will not be able to go through. Okay, and if you put a piece of non-metal in there, then it will not conduct electricity. So that's a comparison between metal and non-metal. And then we say in terms of the ionization energy, and metal has lower ionization energy, meaning it's easier for them to lose electrons. Non-metal has higher ionization energy. So when metal and non-metal react with one another, metal forms a cation, a positively charged ion. So when metal reacts with non-metal, we end up with what we call ionic compound. Okay, and then when non-metal reacts with non-metal, you end up with the same compound. So sodium chloride, metal, non-metal, is an ionic compound. Where water, H2O, that's a molecular compound. We'll get into the details about how we define the ionic compound, molecular compound. What's the difference? What's the similarity? We'll get into the details about that a little bit later, either in this chapter or in the chapters that follow. Okay. So this is a comparison in terms of the physical property and of the metals and non-metals. They're quite different, as you can see. Okay. So that's our second learning objective there. And what we did here is that we introduced the periodic table to you, and we give you the organization of the periodic table. So there are groups, there are periods in the periodic table. So metals, non-metals, they're located in different positions in the periodic table there. So that's something that you need to what's that M word? Memorize. Okay. And so make sure you pay attention to the organization of the periodic table. Now that we know what a periodic table is, and now we know the organization of the periodic table, in the next learning objective, we want you to be able to determine, based on the metals and non-metals we talked about, we want you to be able to predict charges on the ions there. Because atoms are most of them are very reactive.